So we're going to continue our discussion of continuity with this example. We want to determine if f is continuous at x equals 0. You can see f is defined with this piecewise function. So we use the top equation for x smaller than 0 and the bottom equation for all x's equal or greater than 0. So how are we going to figure out if this is continuous? Well, let's think about the checks we talked about previously. The first thing we need to check is there a point at 0? So to do this, I'm just going to go ahead and put 0 in and see if we have a point, alright? So let's plug 0 in, alright? And because it's at 0, we're going to use our bottom equation, so we're plugging into e to the negative 4x, alright? So that's going to give me e to the 0 or 1. Alright, so this tells me that we have a point at 0 and that that point is 0, 1. Alright, that's nice. The next thing we need to check is, do the sides meet up? How do you do that? Alright, well, if you think about it for just a second, think back. If you had a graph, right, let's say here's some graph. It's not of f, it's just some graph. If we looked at a single point and we looked around it and we wanted to know, how does it behave around? Do the sides meet up? Do they do different things? We talked about how we can use a limit to figure that out. And that's exactly what we're going to do here. So if I wanted to know if these sides met up, I would find the limit as x, or find the limit around this point, so as x goes towards whatever point we're curious about. And if I could find this limit, I could then see, do the sides meet up and do they match my point? So that's what we're going to do here. We want to find, and in this case we're looking at 0, so we want to find the limit around 0, so we do x arrow 0 of f. Okay. Well, how do we figure this out? This one's a little bit tricky because the two sides are different. So what we're actually going to do is we're going to see, do these two sides meet up? Okay. So to do this, we'll answer this in a second, but before we do that, we're going to go over here and we're going to see, when I put 0 in here, what do we get? So if I plug 0 in, I get e to the negative 4 times 0, which is e to the 0 or 1. So we know one side is going towards 1, and let's plug into the other and see what's happening when it gets close to 0. So we're going to plug it in, and I'll have 1 minus 2 sine 0, which is 1 minus 0 or 1. Now this is really interesting. If we look, it looks like one side is near getting close to 1. Looks like the other side is also. Since these sides match, we know that this limit must be 1. Okay, now think back. We also know the point, right? We also know that there's a point at 0, 1. Alright, so we know the sides meet up at 1. We know the point is 0, 1. So what that tells us is that the sides, alright, look here, the sides and the point meet up or match. So that tells me that this must be continuous.